Alright, welcome to today's class. In today's class, I'm going to solve Rivers State University physics test question for 2019/2020 academic session. Before we proceed, if you've not subscribed to this channel, kindly subscribe now. And in the course of this tutorial, if you have a question, endeavor to leave your question in the comment section of this video. Alright, so this is question 1A. It says, calculate the diameter of a ball which falls at a rate of 2.94 times 10 raised to the power negative 2. Oil is 0.5 kilogram per meter. 0.5 kilogram per meter per seconds. The density of the oil and the ball are 920 kilogram per meter cube and 7,700 kilogram per meter cube respectively. Acceleration due to gravity G is equal to 9.8 meter per second square. Alright, so this is the question. So how do we solve this question? Solution. Our major task here is to write down the given parameters. Let's look at the question again. Calculate the diameter of a ball which falls at a rate of 2.94 times 10 raised to the power negative 2. Alright, let's write down the given parameter. The first parameter here is known as what? The first parameter here is terminal velocity. Terminal velocity. Terminal velocity. Terminal velocity V subscript T is equal to what? 2.94 times 10 raised to the power negative 2. 2.94 multiplied by 10 raised to the power negative 2. Alright, so this is a question on terminal velocity. And then it says oil is 0.5 kilogram per meter per seconds. Alright, so we have here viscosity. 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 Viscosity is equal to what? Viscosity is equal to 0.5 kilogram per meter per second. So we have here 0.5 kilogram per meter, and then what? Per seconds. Alright, let's check the next parameter. It says the densities of the oil and the ball are 920 kilogram per meter cube and 7,700 kilogram per meter cube respectively. Alright, so we have the density of the ball and the density of the oil. The first density given is what? The first density given is 920 kilogram per meter cube. And the second density given is equal to 7,700 kilogram per meter cube. Alright, so we are also told that acceleration due to gravity G is equal to 9.8 meter per second square. So G is equal to 9.8 meter per second square. Alright, so these are the parameters that were given in the question. So what do we do next? Remember, we are told to find the diameter. We are told to find the diameter of the ball. Diameter of the ball. And remember, diameter is D. So we are told to find the diameter of the ball. Alright, so the formula that relates all these parameters together is terminal velocity formula. Terminal velocity, V subscript T, is equal to 2r raised to power 2 multiplied by G all over 9 multiplied by the viscosity. 9 multiplied by viscosity all multiplied by density rho naught minus rho subscript F. Alright, so this is the formula that relates all the parameters given in the question together. Alright, now let me describe the parameters given in this formula. Vt is known as terminal velocity. Terminal velocity. And then the next parameter here is R. R is known as the radius. R is known as the radius. Alright, so what's the next parameter here? We have G. G is known as acceleration due to gravity. Acceleration due to gravity. Alright, so what's the next parameter given? The next parameter given is viscosity. We have here viscosity. This is the sign or the symbol of viscosity. Alright, so what's the next parameter given? We have rho naught. We have a rho naught. What is rho naught called? This is called the density of the falling object. The density of the falling object. And then finally, rho subscript F is called the density of the fluid. Density of the what? Of the fluid or medium. Alright. So this is the formula that relates all the parameters given in the question together. Now, how do we apply this formula? Remember, we are told to find the diameter of the ball, and diameter can be gotten if we find the value of radius. Diameter can be gotten if we find the value of radius, and radius is in this equation. So now let's find the value of radius, because radius is not given in the question. Alright, let's read the question again. The densities of the oil and the ball are 920 kilogram per meter cube and 7,700 kilogram per meter cube respectively. Now, if you look at the question very well, you would see that the ball is falling. Calculate the diameter of a ball which falls. So it is the ball that falls. So the density of the ball becomes what? Alright, so the density of the ball is rho naught, and this other one is rho subscript F. Remember, we are given the density of the ball. The densities of the oil and ball are 920 kilogram per meter cube and 7,700 kilogram per meter cube respectively. So 7,700 kilogram per meter cube is the density of the what? Of the ball. All right, so if we substitute into this equation, we are going to have 2.94 times 10 raised to the power negative 2 equal to 2 arrow raised to the power 2 multiplied by g. What is g? 9.8 all over 9 multiplied by the viscosity. The value of viscosity given is 0.50. All right, so this will multiply. What is the density of the falling object? The density of the falling object, which is rho naught is equal to 7,700 kilogram per meter cube. So we have here 7,700, and then minus what is the density of the fluid, which is the oil, 920, and then you close your bracket. All right, so we are going to simplify further. So this gives us 2.94 multiplied by 10 raised to the power negative 2 is equal to 2 multiplied by 9.8 will give us what? It will give us 19.6 and then arrow raised to the power 2 all over 9 multiplied by 0.50. It would give us 4.5 and then all multiplied by 7,700 minus 920 would give us 6,780. All right, so we are going to have 2.94 multiplied by 10 raised to the power negative 2 equal to 19.6 arrow squared multiplied by 6,780. What will it give? All right, so we are going to have 132,888 and then arrow raised to the power 2 all over 4.5. All right, so we are looking for the value of r. So at this juncture, we are going to cross multiply. All right, so if we cross multiply, we are going to have 132,888 arrow raised to the power 2 equal to 4.5 multiplied by 2.94 multiplied by 10 raised to the power negative 2. We are going to have 132,888 arrow raised to the power 2 equal to 4.5 multiplied by 2.94 times 10 raised to the power negative 2. So we are going to have 0.1323. All right, so at this juncture, we are going to divide both sides by the coefficient of r. So if we divide both sides by 132,888 and then the right hand side 132,888. So 132,888 cancels off 132,888. So we are left with r root squared is equal to what? 0.1323 divided by 132,888 what will it give? So we are going to have 9.95 multiplied by 10 raised to power negative 7. So we are going to square both sides since r is raised to power 2. So if we square both sides, r will be equal to square root of 9.95 times 10 raised to power negative what? 7. So therefore, r is equal to, kindly punch your calculator, square root of 9.95 times 10 raised to power negative 7. You would have 9.95 times 10 raised to power negative 4. Remember, the unit of radius is meter. So radius is measured in meter. So our answer becomes 9.95 times 10 raised to power negative 4 meter. Alright, so since we've gotten the value of r, let's now find the value of diameter. Remember that diameter d is equal to 2r. Remember that diameter is equal to 2 multiplied by radius. So if we substitute the value of r here, we are going to have d is equal to 2 multiplied by 9.97 multiplied by 10 raised to power negative 4. Alright, so kindly punch your calculator. D is equal to 2 multiplied by 9.97 times 10 raised to power negative 11. What will it give? It would give 1.994 times 10 raised to power negative 3. Remember, diameter is measured in meter. So we have here meter. Alright, so this is our final answer.